The sum of two numbers is 5. The difference between the numbers is 0.5. What are the numbers? So if we know that the total of two numbers is 5, we can find half of 5, or 5 divided by 2, and that gives us 2.5. So it tells us that the average or mean of the two numbers will be 2.5. Now the difference is 0.5, and if we divide 0.5 by 2, or find half of 0.5, that gives us 0.25. So one number will be 0.25 larger than 2.5, so that's 2.75, and then the other number will be 0.25 smaller than 2.5, so that's 2.25. So our numbers are 2.25 and 2.75. If we add these numbers, we'll get a total of 5, but if we subtract, we'll get a difference of 0.5. There are 60 grams of rice in one portion. How many portions are there in a 3 kilogram bag of rice? So we need to remember that there are 1000 grams in a kilogram. So if we have a 3 kilogram bag, that's 3000 grams. So they've given us the total amount and the amount in one portion. So we need to find how many portions, which means we need to use division. We need to divide the total amount by the amount in each portion, and that will give us the number of portions. So we can work out 3000 divided by 60. Remember, when we have end zeros in a division question, we can cancel one end zero, and then we have 300 divided by 6, so that's 50. Because 30 divided by 6 is 5, and then even after we've cancelled, we still have one end zero in our dividend, so we need an end zero in our quotient. So that's 50 portions. The other way to divide would be to count up in 60 grams until we get to 3000. So 60 grams is one portion, so we can work out 6000 grams by multiplying 60 by 100. So that means 6000 grams is 100 portions, but because we only want 3000 grams, we can divide by 2, because 6000 divided by 2 is 3000, and then 100 divided by 2 is 50. Or again, we could start with 60 grams is one portion, but we could multiply by 10 to get 600 grams as 10 portions, and then if we're on 600 grams and want to get to 3000, we can multiply by 5, and then 10 times 5 is 50. Here is a sequence of patterns made from octagons and squares. The sequence continues. How many squares will there be in the pattern that has 40 octagons? So if we look at the number of squares, we have 4, then 7, then 10, then 13. So the number of squares is going up by 3 each time. So that tells us that we multiply the number of octagons by 3. But then if we write our 3 times table next to our numbers, so 3, 6, 9, 12, and the reason we're writing the 3 times table is that we're adding 3 each time, then we can see that the number that we have is always one more than the number in the 3 times table. So what we do is multiply the number of octagons by 3 and then add 1. So 1 times 3 plus 1 is 4, 2 times 3 plus 1 is 7, 3 times 3 plus 1 is 10, 4 times 3 plus 1 is 13. So if the number of octagons is 40, that will be 40 times 3 plus 1. So 40 times 3 is 120, plus 1 is 121. So there will be 121 squares. So to recap, the way to solve this problem is to see what we're adding each time. We could see that we're adding 3 each time, so we wrote our 3 times table next to our numbers. Then we could see that the number we had was always 1 more. So that tells us that we multiply by 3 and then add 1. So Q represents the number of squares. N represents the number of octagons. What is the rule connecting Q and N? So we need to write a formula. We can have Q equals 3n plus 1. Because remember, if we write a number and then a letter next to each other, that means multiply. So Q equals 3 times n plus 1, or the number of squares equals 3 times the number of octagons plus 1. 500 children started a 20-kilometre sponsored cycle ride. This graph shows how far they cycled. At what distance were exactly half of the children still cycling? So we know that there were 500 children altogether. So we need to find half of 500, or divide 500 by 2, and that gives us 250. So we need to know at what distance were 250 children still cycling. So we have the number of children cycling on this side, and 250 will be right in the middle of 200 and 300. So we can draw a line across to where it hits the line on our line graph, and then draw a line down to find the distance. If we look at this scale, we can see that each square is an increase of 2 kilometres. So that means 250 children, or half of the 500 children, were still cycling at 16 kilometres. Now estimate how many children completed the 20-kilometre cycle ride. So we have 20 kilometres at the end, and if we draw a line across, we can see that that's just under 200. Remember, the line in the middle of 100 and 200 will be 150. But the line that we've drawn is closer to 200 than it is to 150. So I would estimate 185, because that number is only 15 less than 200, but it's 35 more than 150. And that makes sense because the line that we've drawn is closer to 200 than it is to 150. So you get the mark for an estimate of between 180 and 190. X is a whole number. 40 is less than x is less than 45. So x could be 41, 42, 43 or 44. So whole numbers between 40 and 45. Now k is a whole number. 29 is less than 2k is less than 35. We need to write what k could be. So we know that 2k could be 30, 31, 32, 33 or 34. And 2k means 2 times k. When you have a number and a letter written next to each other, that means multiply. So if 2k is 30, that would mean k is 15, because 2 times 15 is 30. So to find k, if we know 2k, we can find 1/2. But with 31, if we find half of 31, that would be a decimal. We would get 15.5, but we're told that k is a whole number. So let's move on to 32. If we divide 32 by 2, that gives us 16. So 2 times 16 is 32. 33 Again, if we find half, that gives us 16.5, so a decimal, not a whole number. But if we divide 34 by 2, we get 17. So 2 times 17 is 34. So that means k could be 15, 16 or 17. Now w is a whole number. 18 is less than 3w plus 1 is less than 24. What could w be? Well, 3w plus 1 will be between 18 and 24, so that's the numbers 19 to 23. And if 3w plus 1 is 19, that means 3w would be 18, so would be 1 less, because 18 plus 1 is 19, 19 plus 1 is 20, and so on. So our possible values for 3w are numbers between 18 and 22. So that's 3w, but we just want w. So remember, 3w means 3 times w. So if we just want w, we can divide by 3. So 18 divided by 3 is 6, because then if w is 6 and we have 3w, we have 3 times 6, so 18. If we divide 19 by 3, we get a remainder, but we know that w is a whole number, and 20 divided by 3 gives us a remainder as well. But 21 divided by 3 is 7, so 3 times 7 is 21, and 22 divided by 3 again gives us a remainder, so the only possible values of w are 6 and 7. The shaded triangle is a reflection of the white triangle in the mirror line. Write the coordinates of point A and point B. So let's look at point A first. We know that when we're writing coordinates, we always write the x coordinate first and then write the y coordinate. So if we go down to find the x coordinate, we can see that point A is in line with this point here, which has an x coordinate of 11. So that means the x coordinate, the first number in the coordinate of point A, will be 11 as well. And then to find the y coordinate, we look across and we can see that point A is in line with this point here, and that has a y coordinate, a second number of 9, so the y coordinates for point A will be 9. Now we need to look at point B. Now we don't know what the x coordinate is, but we can work it out by plotting what we do know on our x-axis. So we know that this point here has an x coordinate of 1, because that's the first number in the coordinate, and this point here has an x coordinate of 5. So notice we need to find this point here, but this difference here between these two lines that I've drawn will be the same as the difference between these two lines, because when we reflect shapes in a mirror line, lines always stay the same length. So we can work out that the length of this line must be 4, because 1 plus 4 is 5. These numbers have a difference of 4, so the length of the line at the bottom of the triangle will be 4, which means that when we reflect it, the length at the bottom of the triangle will be the same. So we know that these lines at the bottom of each triangle will have a difference of 4. So 11 plus 4 is 15, which means that point B must have an x coordinate of 15. And then for the y coordinate, we can see that point B is in line with this point, and this point, and they all have a y coordinate, a second number of 3. So that means the coordinates for point B are 15, 3. Alfie has some photographs printed. The cost is £2.50 for postage and 12 pence for each print. Alfie uses this formula for the total cost, C, in pence. C equals 250 plus 12n, where n stands for the number of photographs. So the total cost in pence is 250 because £2.50 is 250 pence, plus 12n, which means plus 12 times the number of photographs. And remember, we need to do 12 times the number of photographs first because we multiply before we add. Now we know the total cost for Alfie is £6.70. How many photographs does he have printed? Well, 670 pence is the same as £6.70, and the formula gives the total cost in pence. So instead of C, we can write 670 equals 250 plus 12n. So let's work out what 12n could be. To do that, we can subtract 250 from 670, so that tells us that 250 plus 420 will give a total of 670. So we know that 12n must be 420. But we want to find n because we want to know how many photographs. If we know that 12 times n is 420, to find n we can divide 420 by 12, and we might need to use short division for this, but that will give us 35. So that means Alfie has 35 photographs printed. 12 times 35 is 420, plus 250 is 670. So 670 pence, the same as £6.70. This square is divided into 3 parts. Part A is 1/3 of the area of the square. Part B is 2/5 of the area of the square. What fraction of the area of the square is part C? Well, first, we can work out the total fraction that's covered by A and B together, and then we can subtract that total from 1 to find the fraction covered by part C, because the whole square is one whole. So we can work out 1/3 plus 2/5. When we're adding fractions, we need the denominators to be the same, and 15 is in both the 3 and the 5 times tables. 3 times 5 is 15, 1 times 5 is 5, 5 times 3 is 15, 2 times 3 is 6. So we keep the denominator the same, and 5 plus 6 is 11. So A and B together cover 11/15 of the square. But we want to find the area that's covered by part C. So what we can do is subtract the area that's covered by A and B together from one whole. So that's one whole square. Remember, one whole is the same as 15/15, because if the numerator and denominator are the same, we have one whole. And 15/15 minus 11/15 is 4/15, because 15 minus 11 is 4. So that means the fraction of the area of the square that's part C is 4/15. 272 children and 26 adults from Hill School go on a coach trip. How many 42-seat coaches does the school need to hire? Well, first, let's work out how many seats they'll need. So how many people are going on the trip? So we can add 272 and 26 to give us 298. So now we need to divide 298 by 42, and the easiest way to do that is to count up in steps of 42 until we get past 298. So 42 seats will be one coach. If we add another 42, that means that we can get 84 people on two coaches. Another 42 gives us 126 for three coaches. And now we could keep on adding 42, but 298 is still a lot more than 126. So what we can do instead is double, because if we know that there are 126 on three coaches and we add another three coaches, that will give us the total for six coaches. So 252 people can fit on six coaches. If we add another coach, that gives us 294 for seven coaches. So we're now very close to 298. But if they only order 7 coaches, then there will be 4 people, 4 adults or children, who can't get on the coach. So they need one more coach for the 4 extra people. So that's 7 coaches plus another coach for 4 more people means they need to hire 8 coaches altogether. Here are 5 number cards. Write the missing number so that the mean is 2. So we need to remember that the mean is the average. It's what you get when you divide the total by the number of things that you have. So we have the total of these numbers divided by 5 because we have 5 cards altogether equals 2 because that's the mean. Now 10 divided by 5 is 2, so that means the numbers that are on our cards will need to give a total of 10. 1 plus 4 plus 1 plus 1 is 7, and then we need 3 more to make 10, so our other number must be a 3. That way, when we add up the total of the numbers, we get 10, and if we divide that by 5, because we have 5 numbers or 5 cards, that gives us a mean of 2.